All right, our lesson on 4.7 is giving us, I believe it's our 5th method of solving a quadratic, and that is the method of solving through using the quadratic formula. So, we have seen the quadratic formula before. This is it. And you were probably asked to memorize it back in 8th or maybe 9th grade when you had Algebra 1, and I'm going to ask you to do the same thing here in Algebra 2. So the first thing we have to do is get our quadratic in standard form, which means all variables and constants have to be on the left-hand side, and then it has to say equals 0 on the right-hand side. Once you are in standard form, you're going to be able to identify the A, the B, and the C, because they are the coefficients to your quadratic equation. C is the constant value. So the formula itself starts off with x equals. That's because you're going to be finding the solutions for x. So right here it says negative b. As mathematicians, we read that as the opposite of b, and then add and subtract the square root of b squared minus 4ac, all of that being divided by 2a. So the plus or minus symbol in the formula is how the quadratic formula develops into two answers. So if you're b squared minus 4ac, and you'll find that right inside the radical here, that's called the discriminant. It's a vocab word we're going to use quite a bit today. If your discriminant is something that's not 0, you're going to end up with two solutions every single time. So when we factored a quadratic equation, we often ended up with two solutions. When we square rooted, we ended up with two solutions. When we completed the square, we ended up with two solutions. And that's because if I look at the graph of a quadratic function, which is a parabola, the solutions are where your parabola intersects the x-axis. So this is an example of a parabola or a quadratic that has two solutions. There is a case where your parabola only has one solution. Oops. And that would be where your parabola ends up, I didn't do a good job here, but it'll bounce off the x-axis and only kind of touch once. And there's actually also a case where your parabola will not cross the x-axis at all, like up here in no man's land. And in that case, we're going to say that we have no real solutions, but we're going to learn next week that just because you have no real solutions, that doesn't mean you don't have solutions. It actually means you have two imaginary solutions. So we're going to come back to that next week. So let's look at an example of us using the quadratic formula to solve a quadratic equation. Now, of all the methods we've learned over the unit so far, the quadratic formula is the only method that can solve every quadratic on the planet. So if you want a surefire method for solving a quadratic, the quadratic formula is the way to go. So first thing I notice here in this example, my equation is not in standard form. I'm going to have to take this 4 and subtract 10 to the left-hand side. So when I rearrange it into standard form, it becomes 2x squared plus 3x. That'll become a minus 4. And then equals 0. So now with it being in standard form, I should be able to identify the A value, the B value, and the C value. So down here, let's figure out who A, B, and C are. So the A value is the quadratic coefficient, the one in front of the x squared, so 2. The B value is the linear coefficient, the one in front of the x, so 3. And the C value is the constant, which is a negative 4. So the quadratic formula, it is kind of a mess, but it's up above your paper here. I'm going to rewrite it. It's the opposite of b, plus and minus, square root of b squared minus 4ac, and then that whole numerator is being divided by double the a value. We're going to do a combination of mental math and calculator math to get the answers correct on this. So let's go ahead and plug in, starting with x equals, and then we start with the opposite of my b term. So if I look at my b term, the opposite value for a positive 3 would be a negative 3. And then we're going to add and subtract, put down a square root symbol. And here's where I kind of differ for some teachers. I want you to go ahead and tell me what b squared is equal to for this problem. So if I take the b value and I square it, I'm going to rewrite that as a 9. And then minus 4 times the a, which is a 2, times the c, which is a negative 4. And then big fraction bar underneath this whole problem. And then instead of writing 2 times a, I just want you to go ahead and double the a value. So if I double my a value, I'm going to divide this whole thing by a 4. All right, we definitely have to simplify this. So what I'd like you to do is on your calculator, don't type the radical, don't type the square root, just type the stuff that's underneath the radical, the discriminant. Please type 9 minus 4 times 2 times negative 4, all as one step. And when someone gets it, they can just shout it out. 41, thank you. So this becomes negative 3, and then we're going to add and subtract the square root of 41, and then divide that number, or those numbers, by 4. Now the lazy mathematician in me is very excited that we end up with the square root of 41, because 41, if I tried to square root it, it'd be funky decimal, and it doesn't break down at all. Like I can't divide it by a 4 or a 9 or a 16. So as a lazy mathematician, I'm super stoked because that means I'm done. Technically, I could leave my answer like this, answers. I keep saying answers because how many answers do you see in this problem? There are 2 answers. So if I wanted you to write them separately, one answer is negative 3 plus the square root of 41, and then divide that number by a 4. And my other answer would be negative 3 subtract the square root of 41, and divide that answer by a 4. Now if this was an application question, which you do have one on your bookwork for homework tonight, they're not going to want you to leave your answers looking like this. That's weird and ugly. They actually would prefer a decimal on an application question. So on your calculator, you would go ahead and you would type negative 3 plus square root of 41 and either put that in parentheses or hit enter before you divide by 4. And then same thing over here with the negative 3 minus the square root of 41 divided by 4. So you'd get your 2 decimal approximations, and then you might decide one of the answers doesn't work for the problem. We'll talk more about that tomorrow. But since you're ending up with 2 answers, one of them might be extraneous. We will discuss that in depth tomorrow. You guys don't need to type that right now. Let's try a few more examples together here. So number 1, I want you to find the solutions through the quadratic formula. So I would like you to start by first identifying, is the quadratic in standard form? And it is. So your next step is to identify who your A and your B and your C are. So the A value is a coefficient of negative 1. The B value is a 7. And the C value is a negative 3. So plugging in or substituting in those values, the formula starts off with the opposite of B. So the opposite of your B term would be a negative 7. And then we're going to add and subtract, put down a big square root symbol. And then instead of writing 7 squared, I want you to go ahead and tell me what 7 squared is. It's a 49. Minus 4 times the A, which is a negative 1, times the C, which is negative 3. And then as far as setting up goes, I'm going to put a big fraction bar. And we're going to divide it by double the A value. So what would you have if you doubled your A value? You'd have a negative 2. So on your calculator, I would like you to compute just the discriminant, not the square root, just what's under the square root. So 49 minus 4 times negative 1 times negative 3. I need a little calculator help with that. 37? Okay. So again, lazy mathematician, very excited, because if I tried to square root 37, it doesn't go well. It's a decimal. And 37 doesn't have a square root inside of it, perfect square inside of it. So my answers are actually right here, negative 7 plus square root of 37 over negative 2, and negative 7 minus square root of 37 over 2. As a lazy mathematician, leave your answer looking like that. Answers looking like that. Okay, we have a bit of an issue here with number 2, though. When I look at number 2, it is not in standard form. So I'm going to have to subtract this 10 over so it's in standard form. We have x squared plus 6x minus 10 equals 0. So I should identify who my A and B and C are. What's the coefficient in front of the x squared? There's a 1 there, right? And then the B value is a 6, and the C value is a negative 10. All right, let's start plugging in the right numbers. So the formula goes opposite of B. So negative 6 plus and minus square root. I want you to go ahead and tell me what B squared would be. Instead of writing 6 squared, go ahead and write 36. Minus 4 times A times C. And all of that is being divided by double A. So double A would be 2. So on your calculator, I want you to simplify the discriminant first. And then we have kind of bad news for my lazy mathematicians out there. What do you guys get underneath in that discriminant? 76. Why is that bad news? As far as lazy people go, me included. 76 breaks down, people. It's not a perfect square, but he does have a perfect square as a factor. So take 76 and please start dividing him by numbers like 4 or 9 or 16. See if any of those divide into 76. 4 times what? 19? Okay. So the square root of 76 is really the square root of 4 times square root of 19. So if I wanted you to reduce that completely, you'd be looking at 2 square roots of 19. And that's what we have to do down here. So this becomes negative 6 plus and minus 2 square roots of 19. That says 19 over here. I think it got cut off on your screen. Over 2. We're not done. Because now that it's simplified like that, each one of my terms here, my coefficients, they're all divisible by the same common term. What can you divide by for a 6, a 2, and a 2? They're all divisible by 2. So what would happen if I divided each one of these numbers by a 2? I'd be left with negative 3 plus and minus. You could write a 1 here, or you could just write nothing. And then the square root of 19. And what happened to my denominator? It's a 1, so I don't have to write anything. There are your solutions, guys. Yuck. So do you see what I mean by it's actually bad news if you end up with a radical that you can simplify? Because then you got to simplify the radical, and you possibly have to simplify the whole fraction set. So kind of annoying. We're going to skip around a little bit because I'm sure you're running out of space. Let's do number 3, and we'll skip number 4. So if you were looking for some space, we're going to totally skip number 4. Okay, number 3. Unfortunately, it's not in standard form yet, so the first thing I need you to do is rewrite it by, I would subtract the 4x and subtract the 3. I like to have my first term positive. You don't have to set it up that way. I just like it that way. So with the way I set it up, the a value is a 2, the b value is now a negative 4, and the c value is now a negative 3. Let's go ahead and plug and chug into the quadratic formula. So it starts off with the opposite of your b term. What is the opposite of my b term? Instead of negative 4, now it's going to be a positive 4. Plus and minus, big square root sign. And again, instead of writing negative 4 squared, what is negative 4 squared? It's a 16. What do you think is always going to be true about this first number in the discriminant? It's always going to be positive. Very good. So 16 minus 4 times 2 times negative 3. And then once I simplify that, the whole numerator is being divided by double my a value. What is double your a value here? 2 times 2 would be a 4. Okay, on your calculator, I would like y'all to simplify. Whoops, that's a 16. Got cut off. 16 times, minus 4 times 2 times negative 3. It's a 16. 40, thank you. So far, I have 4 plus and minus the square root of 40 over 4. All right, as far as a lazy mathematician goes, this is bad news. 40, not a perfect square, but 40 does break down into 2 square roots of 10, because the square root of 40 is really the square root of 4 times the square root of 10. So it'd be 4 plus and minus 2 square roots of 10. All of that being divided by a 4. Okay, double bad news. Still not done. Each one of these coefficients, 4, 2, and 4, they can all be divided by the same number. What is their number? 2. So cut them all by 2. This guy becomes a 2, this guy becomes a 1, and this guy becomes a 2. So my final answers are 2 plus and minus. You can put a 1 in front, or you can just say the square root of 10 divided by 2. Notice I did not divide the 10 by 2. I didn't make this a 5. And that's because it's not a 10, it's the square root of 10, which is a total different number. So right there are your 2 answers. Kind of ugly, but that's all right. real quick, just because I know it comes up on your homework a few times, what if I did all the algebra? And you don't have to write this example down, but, oh gosh, I got to make one up real quick. Okay, so what if I asked you to solve this guy through quadratic formula? So we go x equals the opposite of b, plus and minus, square root, b squared would be 49, minus 4 times a times c, and then all of that being divided by double a, so 2. Now watch what happens when you simplify this discriminant. 49, this will be a minus 40. This discriminant comes out to the square root of 9. So what is the square root of 9? It's 3. So your problem simplifies down to negative 7 plus and minus 3, all of that being divided by 2. Notice, I no longer have any sort of radical stuck in my answer. This is similar to when you completed the square. I asked you that if you ended up with answers that no longer were radical answers, I need you to take it all the way to the final solutions, and you should get fractions or sometimes an integer. So one of the solutions is negative 7 plus 3, and then divide that sum by 2. The other solution is negative 7 minus 3, and divide that sum by 2. So if I did this on my calculator in one step, I just got to make sure I group my numerator in parentheses like this, but I think you guys can handle this in your head. Negative 7 plus 3 is negative 4, cut in half would be a negative 2. And negative 7 minus 3 is negative 10, cut in half is negative 5. So you will find the first few problems on your homework tonight in your bookwork, they simplify all the way down to integers or sometimes fractions, like this one did. So just fair warning on that guy. All right, a little bit more I want to talk about quadratic formula, and I'm going to very specifically look at the discriminant portion of the quadratic formula. So when they say look at the discriminant, they're referring to the thing, the b squared minus 4ac, that expression that was underneath your radical. And they give you a little chart here that tells you what happens depending on what your discriminant comes out to. So I was just, during my lunch break, I was just making your guys' quiz for next week. And I try to make up your quizzes so that their problems aren't real elaborate. They don't have a lot of things to cancel and reduce. And for you guys, since we haven't learned complex numbers yet, I had to make sure that your quadratics came out to real solutions because you don't know complex solutions yet. So, with that being said, instead of me like guessing and checking and hoping my quadratic worked out great, I was able to calculate the discriminant of a given quadratic. And then from that discriminant, I could tell what kind of solutions I was going to have. And if it came out, and we'll see in a second, if it came out negative, that meant I couldn't put it on your quiz because you guys wouldn't know how to do it. So let's look at the quadratic formula real quick. You don't have to write this down, but the discriminant is what's underneath the radical. So if this number right here comes out to something greater than 0, what's another way of saying a number greater than 0? Positive. So if I took the square root of some positive answer, that would be what we call a real number. It's not always a pretty number, like the square root of 37 is not pretty, but it is a real number. If that happens, you're going to end up with 2 real values. So you're going to get 2 answers. So every example we've done so far has had 2 real values. They're not always pretty, but they are 2 real values. However, if you do the discriminant calculation, b squared minus 4ac, and you end up with that discriminant coming out to 0, that's only going to produce 1 real solution for you. So what would happen, guys, if you took the square root of 0? It's 0. So do you get a different answer if you take a number and add 0, and then take a number and subtract 0? No, you get the same answer twice. So that's why mathematically, if your discriminant comes out to 0, you get the same answer twice, thus you only have 1 solution. Now here's the one we're not going to talk about a whole bunch today. What if your discriminant comes out less than 0 or negative? So you'd end up with, like, I'm making this up, negative 3 plus and minus the square root of negative 6. Are you guys right now today capable of taking the square root of negative 6? Not in the real number system. Now some of you are a little more privy to the imaginary number system, but until next week, I would not be able to give you guys this problem because you don't know how to do it yet. So in this case, because the answers are going to come out imaginary, that means we have no real values for solutions. So over the next few examples here, all I'm going to have you guys do is calculate the discriminant. And then let's move ahead to an example. If the discriminant comes out positive, you're going to be able to tell me something about the solutions. If it comes out 0, you can tell me something about the solutions. And if it comes out negative, you can tell me something about the solutions. So on each one of these, we're going to calculate b squared minus 4ac. Let's do that. So starting with this problem, the b value is like a 1 right here, right? So I do 1 squared minus 4 times the a value is a 1, and the c value is a negative 42. And you can just do this straight on your calculator if you don't want to think. That's fine. Type 1 squared minus 4 times 1 times negative 42, and just tell me what value you get for your discriminant. It's 169. What is it? Yeah? Okay. So 169 is a positive value. It's bigger than 0. So what did we just say about positive values? It's going to give me 2 real solutions. So after you calculate the discriminant is 169, that means that we have 2 real solutions. Notice, I didn't actually find the solutions yet. That's okay. All they wanted to know was, will you have 2 real solutions, 1 real solution, or no real solutions? Let's skip ahead and look at number 9, please. So number 9, if I calculate the discriminant, that'll be 2 squared, I should put parentheses around that, minus 4 times a times c. So go ahead and calculate the value for the discriminant. Is that a negative 16? So since my discriminant came out to a negative value, something less than 0, what does that mean as far as my solutions go? 0 real solutions. Very good. And some of your classmates will tell you that also means you have 2 imaginaries. We'll talk more about that next week. So that's pretty much all I want to talk about for quadratic formula today.